Okay, now we're gonna do the GPU part of what Ruben just did as an intro with remoting as the focus. And now we will put our focus on the GPU side of things. And well, as a good tradition, we call it the Smackdown session. But we want to cover both on-premises and the public cloud. And the question that we always have to ask ourselves, why in the world would we use GPUs in server-based computing? Because that was the original name of what we're doing. And the reason is still the same, because despite the fact that we may have some CAD/CAM applications that really need the GPU, we have those applications on the left side of this slide that like to use GPUs. So if you're using Office, if you're using Windows, the window manager, if you're using one of the browsers, if you use the Adobe creative applications, they all want to use a GPU because they were designed to use GPUs. If the GPU is not available, the operating system, like Windows 10, has to emulate a GPU on the CPU. A CPU was never built to do that, so it will never be the same performance. And Citrix, Microsoft, Nutanix, VMware, Amazon, Ericon, WorkSpot, Parallels, they all have their own remoting protocols, or they extend the existing remoting protocols, and they all take advantage of the GPU for a very simple reason. They use it, number one, for the rendering, which is obvious. So for creating pixels from graphics objects, that is one of the things that GPUs are really good at. But the other thing that GPUs can do is encoding the data stream that goes across the wire. And all of these vendors either use one of these elements, like the rendering or the encoding on top, to improve the performance of their remoting protocols. And you will see examples later today when we present performance sessions. Now, the question is, what are the options that we have out there? So, okay, I'm gonna take the other microphone, and I will be covering the on-prem GPUs first. So in alphabetical order, we decided that we're gonna start with AMD. And this is one of these slides that I'll be using without going to another slide, and I will be talking about that. Good, let's start with AMD. They started with what is referred to as MX GPU in 2016. So they released the FirePro S7150, which is based on one Tonga GPU with like almost 2,000 shader units. And what they do is they assign dedicated physical slides of the shaders and the frame buffer, the video memory, to an individual virtual machine. And this is very different to other technologies that are out there. Then AMD also released the FirePro S7150X2, which has two Tonga GPUs on one board. So we have 2 times 1792 shader units, plus we have a number of compute units that are good for doing some deep learning algorithms. So these are all on the board. That was released in 2016. Unfortunately, it did not enjoy a lot of success in the market, as Ruben pointed out in the previous session when he showed the results from AMD. But now they are working on much newer ones. It's the Vega series of GPUs. So it's basically the Radeon Instinct GPUs that they're working on, or the boards. Some of them have already been published. They have been released. Others are still in the pipeline. And this is sort of the upcoming version of the GPUs delivered by AMD. And they come with more than 4,000 shader units per GPU, which makes it really attractive in terms of performance. But what we found out when we started testing AMD GPUs is that it needs to be in fine balance with the CPU. If CPU resources are not equally provided, then all the GPU power cannot help you. And so this is why AMD also works massively on the EPYC CPUs, so that they, combined with the Instinct GPUs, can provide the best performance. So AMD released the EPYC 7001 CPUs called Naples earlier this year, and they are working on releasing the upcoming version of their CPU. The interesting thing here is that Naples has 32 physical cores, which allows you to use 64 threads if you're using hyperthreading. So it looks like the Rome CPU will double this, so bringing it up to 64 cores and 128 threads. And you can have boards, server boards with 2 of these CPUs. So that makes it very, very scalable in the data center, both in the cloud and on-prem. So I'm really looking forward to testing that kind of GPUs. Okay, talking about Intel. Intel is the next one. So they only have integrated GPUs in their CPUs. So it is not as spectacular as you would think, but they are working on it like crazy. And the interesting thing is that if we're looking at the latest version of what they have, it's the Gen 11 Ice Lake CPU they have. That comes with a built-in GPU with 512 shader units. So, and it only uses 15 watts. So they're getting closer and closer to what other GPU vendors were able to do in the past at a much lower power consumption. In addition to that, there are plans that were published by Intel that they want to release a discrete GPU card in 2020. So they want to use the knowledge that they have collected over time with their APUs, with their built-in GPUs in a CPU, and they want to put that out in the market in a discrete way. So the final vendor is NVIDIA, and they have invented this market. Basically, they have invented the grid technology, which is not called grid anymore. So today it's vGPU, the NVIDIA vGPU technology. So they started with the Maxwell chipsets in 2015, 2016, like the M10, M60, the M6. So these were very, very attractive GPUs at the time, and we all used them for testing. Those were our primary test machines that were using M10s or M60s. And then the Pascal generation was released in 2016, like the P40, the P4, the P6, and more CUDA cores, more memory, relatively low power consumption, very powerful cards. And later on, Ruben will present some results using the Volta, the next generation that was released in 2017. And now we have the Turing generation, the Tesla T4. But I did not have any opportunity to start testing with it. Because it is interesting, because now it has not only the Turing tensor cores, 320 of them, but also ray tracing cores, so that we will be able to use ray tracing side by side with remoting technology. The most important thing to notice is that NVIDIA just released the latest version of the virtual GPU technology, v9.0, which you can look up at the NVIDIA website. And this is it, what I have for on-prem. Take it away, Ruben.
Yeah, I'm back. Yeah, what I always remember is like Tesla is the board and grid is like the software. And in the early days,
yes,
we had like this grid, which was software and board combined. And it's great to see that it's disconnected as well. Alrighty, let's move on. Let's see if I have control. Yep, that's it. GPU options in public clouds. Remember the clouds, so multiple clouds. That's the point. So I want to spend roughly 10 minutes around Azure, AWS, Alibaba Cloud, and GCP. I do have access to 3 of these 4 cloud platforms, Azure, AWS, and Google. Did some testing. I only have 20 minutes, so I want to keep it a little bit high level. And one of the things I want to share first, and this screenshot is from the Azure website, but this applies to actually all the vendors I just mentioned. When you see GPU instance types on cloud platform, like the different instance types you can choose from, really understand what the goal is of that machine. Like an NC series is a compute intensive, network intensive, like instance type. An ND is for deep learning, the D is for deep learning, and an NV is for visualization, remote visualization, like VDI, like our space. The question a little bit later is, okay, can I use an NC for remote visualization, for VDI? That's a question, an interesting question to ask, and I will share later what the response is. So keep in mind, for all the vendors, they have a ton of different GPU options, but not all of these GPU options apply to what you have or what we have in mind with end user computing, with VDI and remote desktop service, session host, and the likes. Alrighty, let's focus right now on Azure. So the workhorse, the cloud workhorse, is an NV6 or an NV12. I see a typo here, or an NV24. Different machine types with the same ingredients. An Xeon V3 2.6 gigahertz with 6 up to multiple hundreds of gigabytes of RAM, with like 65 or multiple gigabytes of RAM, 6 CPUs, or I think the other one is like plus 24 vCPUs, 1 NVIDIA M60 GPU or 4 NVIDIA M60 GPUs, and you pay per time unit for these machines. Storage, what I use in my team or our team, starts with standard SSD, and don't be fooled by the name SSD. Later today, there is a session talking about the cloud practical way. I will share more insights about storage and public cloud, including Azure. And you will be surprised by the name SSD. It's good to understand what the Azure NV6 1224 can do. It's just a cloud workstation. I use the NV6 a lot. I added some personal notes to this one. Its code is 2.6 gigahertz, not bad, not too bad. But if you have single-threaded applications which benefit for high clock speed, keep that in mind. This is a 2.6 gigahertz. It's not something like, hey, let's swap out a CPU and use another CPU. It doesn't work like that. It's a Maxwell-based GPU, pretty beefy machine, beefy GPU, but it's not like the most modern GPU. There's no slicing of GPUs. There's no vGPU in Azure. And the NV6 with 6 vCPUs, 65 gigs of RAM, NVIDIA GPU is the quote smallest and also quote cheapest instance type you can choose today from Azure for our workload, a GPU workload. And storage options, be aware. You have standard storage, you have standard SSD, you have premium SSD as well, with different characteristics. Not all instance types support all these storage types, but the NV6 we use a lot is with standard SSD. Again, later today at the, let's see what time it is, I don't know top of my head, but later today we have a group discussion about the cloud in a practical way, and we'll share more about storage. When I run CPU-Z and Cinebench with this machine, you can see the results. Always handy to have some baseline and compare it with on-prem, for instance. Let's move on a little bit faster. AWS, they have 4 different families of GPU types: G2, G3, Elastic Graphics, and graphics. In this case, AMD is being used as part of a service, AppStream, like application remoting. That's what AppStream is. So you cannot buy infrastructure as a service based on like AMD GPUs, because this is like built in into AppStream. G2 is Kepler based, G3 is Maxwell based, like the NV series in Azure, and Elastic Graphics is really designed for OpenGL applications. So it's more like, okay, let's outsource quote OpenGL task to a more centralized unit, and then bring back the results to the actual running instance type. So you can use like a CPU instance type with an elastic graphics adapter, and then can use that. The workhorse is a G3 machine, so G3S.XL is the smallest machine for 4 CPUs, 30 gigs of RAM, an M60 GPU. You can see it here as well. And also they have like extreme beefy machines, like a G3.16XL or 16 extra large. You can see it here as well. Like a beefy machine, like $7 like per hour with using Windows when you want to use that machine. So it's a beefy machine. I've seen this machine more than once in the field as well for specific application which benefit with like this amount of RAM or sometimes even multiple GPUs. I've seen it in the field myself. Some personal notes: the Intel V4 CPU is only 2.3 gigahertz. Is it a problem? Well, sometimes is. Again, with single-threaded applications like Revit, Autodesk Revit is an example. It's okay. But if you're used to use a physical workstation under the desk with like a 3.2 gigahertz or 3 point something gigahertz CPU, yeah, that might be a good double check if this type of machine in public cloud makes sense. No slicing, no vGPU. It's great that Amazon also has smaller workstation sizes. Storage, we use like EBS is like a very good storage platform to use. It's good performance. I will share a little bit more later about that. And you see some benchmark results here as well. I did also run a spec view perf, but based on time, I'm not able to share. I will keep it for a later event for sure. But if you want to know what the spec view score is with this kind of machine, just drop us an email if you are interested. GCP is interesting because GCP already has a little bit more options. TP, P4. In my own testing, I use P4 a lot. So a modern GPU, including NVIDIA licensing. That's not what I shared earlier, but both on the Amazon side and on the Azure side, when you want to rent like an NV6, that includes NVIDIA licensing. So you don't need to worry about license services and cost and these type of things because that's already included in that hourly price of that machine. And that applies to GCP workloads as well. What I find beautiful on the GCP side is that you have more granular control about CPU and RAM. So it's not like more fixed t-shirt sizes, but there's more control, more flexibility to pick the amount of CPU cores or RAM you want to use for that instance type. Some personal notes now becomes interesting. CPU is a 2.0 gigahertz CPU. Meh. And I'm not sure why this is, but my gut feeling is that this instance type originally is designed for machine learning and deep learning. In that scenario, you don't care that much about CPUs. You care about like the GPU cores to do the heavy lifting, and not the CPU, of course. So maybe that's the reason why this 2.0 gigahertz CPU is being used. I don't know. But no slicing of GPUs, no vGPU. Great to have the flexibility, and you can see the CPU-Z and the Cinebench benchmarks here as well. Alibaba Cloud. Or Ali Cloud, it's also great. The beauty of Ali Cloud is that they have even more family types of GPU powered machines with focus on end user computing, but also with focus on non-end user computing, but still benefit with GPU. This one is the one which I found interesting, like the ECS.VGN5. That's the series type. Look at the GPU, P4, 1/8 of the GPU. So yes, you see vGPU, slicing of GPUs here with Alibaba Cloud, which is great. I think Google and Microsoft and Amazon can learn from Ali Cloud in this context to have vGPU, because that will help us to drive costs down of these expensive GPU machines. vGPU is supported here. 2.5 gigahertz Intel Xeon CPU, also good. And there are like different instance types, like T, you can see here, and also the different regions. Sometimes people think Ali Cloud is only like China, like Asia, but it's great to see that also in our region and US, like Middle East, Australia, you can see that Ali Cloud is doing a great job on that side as well. So right on time, I did hear the buzzer here. That's great. So Gabe will be proud of us.
Wow.
Great job, Ruben.
Yeah, good stuff.
Stayed in time.
Yeah, thanks again.
That's amazing. 5
Listening
minutes
in.
early again.
Thanks.